A product is known to have a demand function P, or the dx equals 100 times e to the power negative 0.5x. Part A, we're going to find the value x for which e equals 1. And part B, find the value x that maximizes the revenue. For the function d, or the dx equals 100 times e to the power negative 0.5x, the derivative or the rate of change of the demand function is 100 multiplied by the derivative with respect to x of e to the negative 0.5x. Recall this is e to the power as a function. So name the function as the g of x. And the derivative to find the expression e to the power gx is e to the power gx times the g prime of the x. For our case, the gx is negative 0.5x. Therefore, the g prime of the x is negative 0.5. Now we get the d prime of the x as 100 multiplied by e to the negative 0.5x multiplied by negative 0.5. Simplify the numbers to be negative 50 times e to the negative 0.5x as the d prime of the x. We're going to need the dx and the d prime in the formula to find the elasticity of the demand, Ex, which is 1 over x, negative sign here, multiplied by the dx over d prime of the x. Negative 1 over x times the dx is 100 times e to the negative 0.5x divided by the d prime, which is negative 50 e to the negative 0.5x. We're going to find the x for which e equals 1. The expression for e, before we replace into this statement, so we can simplify it a little bit more. Negative sign can be reduced. The exponential term will be reduced. And then 50 and 100 reduced to be 2 for the numerator. Therefore, the expression for the e, or the function for the elasticity of demand, becomes 2 over x. So we're going to set it as 2 over x equals 1. That tells us x equals 2, which is the quantity x for which e equals 1. And for part B find the x that maximizes revenue. The maximum revenue occurs when the e equals 1. Therefore, the answer is the same as part A, which is x equals 2. Let's maximize the revenue. Or we can prove it by an alternative way. Since the Rx is x times dx, so we're gonna find x by using the R prime and let it be 0, which is the normal routine to find the critical number. But this one is more tedious because the R prime gonna be the derivative of the x times dx, or using the product rule, or it comes out to be the dx plus the x times d prime of the x. And the dx is 100 times e to the negative 0.5x plus x times the d prime, which is negative 50 e to the negative 0.5x. And more work to do. We see the common factor as 50 e to the negative 0.5x. We have 2 minus x in the parentheses. And this is the R prime. And we're going to find the critical number or the critical value x by letting r prime be 0. That means the factor this 2 minus x gonna be 0, where the e to the power never be 0. So we get the same result as using the elasticity of the demand as 2 minus x equals 0, or x equals 2 will be the quantity that maximize the revenue by using the direct method instead of using the elasticity.